Today we are going to set up our working environment to develop on the Solana network and deploy our first contract on the DevNet using Anchor and the Solana tool suite from Visual Studio Code. Anchor is a framework that allows you to create smart contracts or programs as they are known on the Solana network, easily and securely.
To use Anchor, we need to have Rust and the Solana CLI installed on our system, as well as Yarn. Therefore, we will start with these requirements. To install Yarn, we go to yarnpackage.com, link in the description, copy and execute the following command to enable core pack, and then use the next command to install Yarn.
On the official Roots website, link in the description, you will find instructions to install it according to your operating system. On Linux, execute this command in a terminal and choose the installation with the default options, which includes updating the patch environment variable to access Rust from the command line. For the installation of the Solana CLI, we will go to the official CLI page, link in the description, where we will find instruction for the installation process. On Linux, execute the command copied from the page, and after completing the installation, execute the command to update the patch variable, and we can proceed with installing Anchor. To do this, visit anchorland.com/installation, link in the description, and copy and execute the command that will install the Anchor version manager. For our case, on Linux, execute this command to install other necessary dependencies. And with this command, we install the Anchor CLI and configure it to use the latest version. If everything is correct, the command anchor-b will display a result similar to what we see on the screen. We can also execute cargo-b and solana-b to verify that everything is installed correctly. Now, to create a smart contract on Solana, open a folder in Visual Studio Code and execute the command anchor init, followed by the name you will give to the folder that will contain the code and will be the name of the smart contract. You can see all the folders and files that have been created, and within the program folder, you will find the src folder that contains the lib.rs file, where the code of our smart contract will be located. We will refer to the quick note guide on how to write your first contract in Anchor, link in the description, to copy the code for the function that will print the hello world message in our contract. Replace the content of lib.rs file and make sure to place the ID of our contract in the declare ID variable. We can obtain this address from the anchor.tone file. This will be the identity of our contract on the blockchain. With the terminal pointing to this parent directory, we can now run Anchor build to compile our contract. Before deploying our contract to the Solana DevNet, we will configure the wallet for transaction and also configure Solana resources to use our favorite RPC endpoint from QuickNode. On quicknode.com, we will create a new endpoint. Select Solana and then DevNet. Click on Create Endpoint, and now we have our RPC ready to use. In the anchor.tone file, we will change the cluster variable below provider to set our QuickNode RPC. If we run solana config get we can see the configuration that the Solana CLI has. Next, execute Solana config set URL and paste our quick now RPC URL. We can see that this RPC address has been configured in Solana. Now let's generate a new wallet using the command Solana keygen new. The command will print the new public key on the screen, which we can access by executing Solana address. We need to top up this wallet. We will go to solfaucet.com and enter our newly created wallet address. It's important to request 3 Solanas for this task to have enough funds for the operation. The command Solana config set -key followed by the patch to the wallet we have created configures the Solana framework to work with this wallet for all transactions. It's important to know the patch we have used is the default used by the Solana CLI to create a new wallet. Now we deploy our contract using Anchor deploy. After the process is completed, we'll test it using the hello-world.ts file located in the test folder. Modify the name of the method we access in our test code to say hello, which represents the name of our function in our IDL file. Let's execute yarn to install the dependencies. And now let's do Anchor run test to interact with our program. We will take note of the transaction address and go to Solana FM. We will choose Quick Now DevNet and enter the transaction hash. At the end of the page, we can see the Hello World message deployed on the blockchain when performing the transaction from our TypeScript test file. With this, you now have your entire working environment set up to develop on Solana. And in upcoming releases, we will start adding functionality. Don't forget to hit subscribe and see you soon.